Hi, so example 5 builds on example 4. We're going to use compound interest in this one. So $15,000 is invested in an account with an annual interest rate of 6%. We're going to calculate the value after 5 years if A, it's compounding yearly, and B, it's compounding, that's meant to say monthly. All right, so if it's compounding yearly, you don't have much space if you're using the booklet to write this in, so I've gone into columns, and I tend to like to do these problems in columns anyway. It makes it sort of even, and your layout is better. Okay, compounding yearly, we're going to use the compound formula. The amount is equal to the principal plus 1 times 1 plus I to the power of n. Our principal in this case is 15,000. I'll just work on this one first. And the interest rate is 6%, so it's 6% over 100 times the compounding number of times it's compounding in a year, and it's been compounded yearly, so that's 1. So this is n. The I is equal to 0.06. This is meant to be an n. This n is equal to the number of times it's compounding in a year times the year. So that's that k times t I was talking about, the compounding times the time. So here I would have it's compounding once a year, and it's in there, the time is 5 years. So in this case, that's going to be equal to 5. So now I have all the numbers that I need to put into my formula. So A is then equal to the principal, 1 plus 0.06 to the power of 5. And when I put that into my calculator, the total amount is equal to $20,073.38. I'll put a dollar sign here. Alright, so that's compounding yearly. Let's have a look at compounding monthly. The principal stays the same, so it's still that same $15,000. The I now, it's compounding monthly, so remember that the interest rate doesn't change. The interest rate is still 6 divided by 100 for a decimal. Then it's compounding monthly, so I need to multiply that by 12. My n's gone off the page here a little bit, so I'm just going to slide that in so we can see it. Okay, so n is equal to k times t. So it's compounding how many times? Oh, monthly, that's 12. And for 5 years, so that's equal to 60. Now I can put all of those values back into my formula. A is going to be equal to the principal, 15,000, multiplied by 1 plus, I haven't put this into my calculator. Oh yes, here we go, 0.0, this is the I, 0.5, and this to the power of 60. So when I put that into my calculator, I come up with the value of $20,232.75. So if I just slide back and that, see if we can get both of them in the screen, you can see that here, calculating, there are my two answers. So putting it in monthly compounding interest gives me a greater return than if I did here and put it in with annually compounded interest.